Okay, so the next category that we're going to look at is a group frequency distribution. And before we hit this, we have to know something about the classes. So as you noticed up here in this example, the classes were these categories that we place the data in this case. So classes in a group frequency are number distributions. So like, from 50 to 59, or from 1.5 to 3.5 or something like that. So they're this category of values. And so we need to put up some conditions for what should hold true for these class limits, is what we call them. So typically, there should be between 5 and 20 classes. If you have less than 5, then you probably don't need to do a frequency distribution. If you have more than 20, you should limit the number of classes that you have. In the example that we're going to work, it tells us how many classes that we want. Okay, but if it doesn't tell you how many classes, you got to pick how many classes you want for your distribution. And in that case, you want to pick something between 5 and 20 classes. Now, there's what's called a class width. Well, before we hit that, there's something else. Let's back up for a minute. When you talk about classes, you talk about a lower limit of a class and an upper limit of a class. So for example, if I had a class that went from 50 to 59, this would be our lower limit of that class, and this would be our upper limit of that class. Now, if I started listing the classes, so let's say I had something like 50 to 59 was one class, 60 to 69 was another class, 70 to 79 is another class, then what we would want to do, and then you can keep going on with those, what we want to talk about is class limit, or width, class width. Now, when we talk about class width, it's the distance between two consecutive lower class limits. So distance between, I'm having trouble, between two consecutive lower class limits. So for example, over here, if we look, 50 and 60 these are two consecutive classes, 50 to 59 and 60 to 69. Consecutive means one comes right after the other. And the two lower limits are 50 and 60, so the class width would be 60 minus 50, or 10 in this case. It's not the distance between the upper and lower limit of one class, it's the distance between the two lower limits of consecutive classes. Okay? And preferably, but not absolutely necessary, the class width would hopefully be an odd number. So in this case, for example, it's not, but preferably it's preferable, but not necessary, that the class width be an odd number. And the reason this is then the midpoint, this allows the midpoint of the class to have the same place value as the data. meaning if the data is integers, then the midpoint will be an integer. If the data has one decimal place, then the midpoint will have one decimal place. If you have an even number, it kind of splits it can split the midpoint so that it's one more decimal place offered than what was in the data itself. Okay, so we're going to keep going about classes. Classes need to be mutually exclusive. Meaning you can't have a number belong to more than one class, or the classes cannot overlap. Class bound or class limits don't overlap. Okay. The classes must be continuous, so you can't skip numbers. Meaning no gaps. Even if you have a class that doesn't have any data in it, unless it's the first class or the last class, you gotta list it even if it doesn't have any data in it. Classes must be exhaustive. Meaning you have enough classes to capture all the data. And classes must be equal in length. So for example, if I had classes that went 50 to 59, 60 to 65, 66 to 70, this wouldn't work because this length of this class is 9. The length of this class is 5. And the length of this class is 4. They can't have all different lengths. So, excuse me. So these are the conditions for what you can do. There's one exception to this length, though. You can have one exception that occurs if a class is open-ended. So this can only happen in the first class or the last class. So the first class has no lower limit, and or the last class, so it could be and or, the last class has no upper limit. So you could have something like 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 or above. So that would be the last class has no upper limit. It just goes 90 or bigger. In the same respect, you could do something that has up to, let's say, up to 15, and then it starts 16 to 20, 21 to 25, and so on down the line. So the lower class in this case has no lower limit. Okay, so that is all the conditions we can have on classes. And so the next thing that we're going to do is we're going to take an example and create a group frequency. And the steps for this group frequency are on page 47 in your book. So let's do that in the next video.